The Domain Security Metamodel, or DSM, allows experts to capture security knowledge for a specific domain. It uses the CSM as a language for the creation and description of all the security elements. The security domain experts are responsible of the DSM's creation, and they use their expertise to design the different security properties and express all the security concerns belonging to the target domain. The security domain experts analyze a domain in order to define a DSM, and they use a set-free process tool to model all the necessary elements to represent the security knowledge. The process starts with the creation of a new DSM. The SPT automatically creates a new model, including the most recent version of the CSM in it. This process configures a magic draw environment to support the DSM designing process, and it activates several triggers in the system. The metamodeling language is ready to be used, and the validation system is loaded, and it will run in the background. When the new DSM action ends, the environment is ready to start with the creation of security elements. We are going to show the modeling of an example DSM to understand how the security knowledge is represented. An empty DSM is by definition a wrong metamodel, and that's why the validation results show the lack of the mandatory elements to be included in a DSM, like the security solution or the domain instances. The security domain expert uses information about the errors to guide the modeling process and obtain a valid DSM. First of all, the domain security expert renames the DSM model with a more appropriate name that reflects its final content, set-top box DSM. Our example will focus on security properties belonging to set-top boxes with the proper characteristics of these embedded systems. We begin the modeling process with the creation of the domain element. The DSM is created using instances of the metaclasses defined in the CSM. Therefore, once we add a new instance, we locate the domain metaclass to instantiate it, and we assign it for set-top box it. One of the most important responsibilities of the domain security expert is to describe every element of the DSMs, including useful information to explain the purpose of the element and also to properly identify their details to be classified and catalogued. Therefore, the domain security expert describes the domain as this knowledge domain gathers all the security aspects belonging to the embedded system of a set-top box and located in the UMA.S author domain. The next element is an instance of the security property, the secure data. Created by the University of Malaga and also belonging to the UMA.S author domain. This property ensures that all the data stored is protected against unauthorized accesses. The flag internal establishes if the security property owns a solution or if it only provides relevant information. We link the instances and we continue with the security property authorization. Described as it determines whether a particular entity is authorized to perform a given activity, this property is internal because it leaves the realization implementation to be attached in a parent element, the secure data property, establishing a composition and defining a dependency between them. The domain security expert defines the secure data as a property applicable in the target element of type class. Using the standard relationship type of association. A real target instance is required in the DSM to guarantee the proper relationship graph. A system requirement element is necessary to link other elements of the DSM with a final place in a system architecture. Therefore, the domain security expert includes it in a model meaningless at this modeling stage. Finally, a solution instance must be included in a DSM. For example, secure data solution. This element will reference the implementation and the realization of the solution to fulfill the corresponding security property. We have obtained a model which achieves the minimum requirements to be a valid DSM, gathering some security knowledge of the set-top box domain. The validation system shows no error in the model, and we can save it and proceed with the next stages of the modeling process.